Hey everyone, welcome to our video. In this video, we will be discussing the bucket sort algorithm in data structures. But before we begin, make sure that your ears are open and paying attention to this video. Now, without any more delay, let's dive into today's discussion agenda. At first, we will understand what exactly is a bucket sort algorithm. Next, we will understand the working principles of bucket sort algorithm. Followed by that, we will look at the pseudocode of bucket sort algorithm. Finally, we will understand the bucket sort algorithm with complexity. So I hope I made myself clear with the agenda. Now, let's get started with our first concept, that is what exactly is a bucket sort algorithm. So, the bucket sort algorithm divides the unsorted array into several groups known as buckets. So each bucket is sorted using any suitable sorting algorithm or recursively applying the same bucket sort algorithm. I know it's a little complicated to understand, so let's go through an example. So on my screen, we have an example of an array consisting of numerical elements, that is 12, 6, 37, 29, 11, 35, 21, and 22. Now, we will create some buckets with different ranges. So here we have different buckets ranging from 0 to 7, 8 to 15, 16 to 23, 24, and finally, the last bucket with range 30 to 39. So 6 will be stored in the first bucket. Followed by that, 11 and 12 will be stored in the second bucket. Followed by that, we have 21 and 22 stored in the third bucket. Followed by that, we have 29 in the fourth bucket. And finally, the last two elements, which are 37 and 35, stored in the last bucket. In the next stage, all the elements are sorted according to an order that might be ascending or descending. In our case, we have the ascending order, so the final result will be 6, 11, 12, 21, 22, 29, 35, and 37. So this is how the bucket sort algorithm works in real time.
Now, the next topic, that is working of a bucket sort algorithm in a detailed way. So now we know the briefing of a bucket sort algorithm. Now let's learn the working of bucket sort algorithm in depth. Suppose we have 0.47, 0.39, 0.23, 0.55, 0.29, 0.41, 0.59, and finally 0.31. Then we will create an array of size 10 and store 0 in each block. And each block of an array is used as a bucket for sorting the elements. Next, we have a step 2. Insert the elements into buckets from the array, and all elements are inserted as per the range of the bucket. Buckets ranging from 0 to 1, 1 to 2, 2 to 3, up to n1 to n. Here n is the number of elements in an array, and that give us 2.3 approximately equal to 2. So finally, we will insert 0.23 into the bucket number 2. And exact, we will insert other elements into other respective buckets. Followed by that, we have step 3. Elements of each bucket are sorted using disable sorting algorithms. And finally, the step 4. In step 4, all the sorted elements of each bucket will be gathered and represented in the form of an array. We will show a video from YouTube so you can know more about the bucket sort algorithm. We will show a video from YouTube so you can know more about the bucket sort algorithm. We will show a video from YouTube so you can know more about the bucket sort algorithm. We will show a video from YouTube so you can know more about the bucket sort algorithm. We will a pseudocode is an informal programming description that does not require any strict programming language syntax. Similarly, we will understand it effortlessly. So, in the pseudocode, first, we will create n empty buckets. Next, we will insert all the array elements into buckets by multiplying the size of an array. We have to keep doing this for every array elements as we understood this in working of the bucket sort algorithm. After that, we have to sort individual buckets using insertion, sort, and finally, we will concatenate all the sorted buckets.
Next, we will learn about the complexities of bucket sort algorithm. First, we will see about the time complexity. So talking about the time complexity, we usually have three cases to summarize the time complexity. So first, we have the best case. So that the best case is 0 of n plus k. Next, we have the average case that is 0 of n into n. And finally, we have worst case that is 0 of n. Here, n is the total number of elements to be sorted and k is the number of buckets. So let us understand all the three cases one by one. So, first we have the best case. So the best case occurs when all the elements are uniformly distributed in the bucket with an equal number of elements in each bucket. If insertion sort is used to sort the bucket sort algorithm, then overall time complexity is for making the buckets and 0 of k complexity is for sorting all the elements. After understanding the best case, now we will see how the worst case occurs in the bucket sort algorithm. The worst case occurs when they are elements of close range in the array. They are likely to be placed in the same bucket. It makes the complexity depend on the sorting algorithm used to sort the elements of the buckets. Complexity becomes worse when all the elements are in reverse order and if insertion sort is used for sorting. Then, time complexity becomes O of n into n. And lastly, we will learn how the average case occurs in the bucket sort algorithm. The average case occurs when the elements are randomly distributed in the array. It occurs even when the elements are distributed in uniform way. Bucket sorts runs at the linear time. The average case holds true until the sum of bucket sort sizes is linear and in the total number of elements. Next, we will see about the space complexity. So the space complexity of all bucket sort algorithm is 0 of n plus k. Lastly, we have stability. So talking about stability, so yes, the bucket sort algorithm is stable. And that's it for this video. Thank you guys for watching.